let's do another example of graphing rational functions. So let's take the function y equals x plus 1 over x squared plus x minus 6. So we can simplify this into x plus 1 over x plus 3 x minus 2. Let's get our horizontal asymptotes, vertical asymptotes, and slant asymptotes. So horizontal asymptotes, since the degree of the numerator is less than the degree of the denominator, that means the horizontal asymptote is going to be y equals 0. The denominator is getting really, really big, and the numerator is not getting as big, so it's going to 0. Vertical asymptotes, that's where the denominator is 0. So we've got at x equals negative 3, and at x equals 2. There we have it. Slant asymptotes, slant asymptotes only happen when the degree of the numerator is 1 more than the degree of the denominator. In this case, we don't have any slant asymptotes because the denominator's degree is bigger. So let's plot this. So to draw this y equals 0 a horizontal asymptote, that's tricky. I'm just going to darken in, and hopefully it won't be too difficult to see that that is an asymptote by looking at the graph. Alright, got that. And vertical asymptotes. So we've got one at x equals negative 3, which we can put here. X equals negative 3. And one at x equals 2. Right here. X equals 2. Now let's go ahead and make our table. So x and y. When we plug in, I like to start plugging 0 for x because that's the easiest. We just get 1 over negative 6. So that's negative 1/6. So that's like down here. Let's plug in something on this side and this side. At, how about negative 2 for x? Then we get over 4 minus 2 minus 6, which is negative 1 over negative 4, which is 1/4. So now we're up to this side. And at x is 1, which will be like over here, plug in 1, we get 1 over 1 plus 1 minus 6. We get 1 over negative 4, so negative 4. So now we're down on here. So we can kind of see what's happening here. It's crossing here, it's going up this way, and it's going down this way. If you didn't see that off the bat, then you could always plug in more points, like plug in negative 2.5, and you'd get something that's like up here, and then it'd be pretty clear at that point. Alright, what about what's happening at this side of negative 3? Let's plug in negative 4. When we plug in negative 4, we get out negative 3 over 16 minus 4 minus 6, which is negative 3 over 10. So we are down around here. And we can already sort of tell off the bat that it's going to be, it's confined to this segment here. Remember, this is an asymptote here. So it's kind of confined to this segment, and it's going to, well, let's just plug in another point just to illustrate it even better. At negative, let's plug in negative 10, maybe. At negative 10, it goes to negative 9 over 100 minus 10 minus 6, which is negative 9 over 84. So that's even less than 3/10. So now at like negative 10, we're going to be all the way over here if we continue it like that. So this is going to end up looking something like that. And I'm going to make a new xy for this side. Let's plug in x as 3, and for y we get out 3 over 9 plus 3 minus 6, which is 3 over 6, which is just a half. So that's going to be up here. If we plug in like 10 for x, then we get 11 over 100 plus 10 minus 6, so that's 11 over 104, so that's a little bit lower, so we're here. So then we see it's going to look like that. So there's our graph. Thank goodness for asymptotes, I guess, because that helps us kind of see where it's going. We don't have to plug in so many points. We just need to plug in a handful, and then you can just kind of sketch it, getting closer and closer to the asymptote. Cool, we're done.